Hello everyone, myself Soumya BJ, Assistant Professor, Department of ECE, SJBIT. The subject is Digital Communication and the subject code is 18AC61. The topic of discussion is Digital Modulation Techniques. In Digital Modulation Techniques, we are discussing about the phase shift keying techniques using coherent detection, in which first we will discussing about generation, detection and error probabilities of BPSK and QPSK. Later on we will be discussing about M-array PSK and M-array CAM. Then we will be discussing about frequency shift keying techniques using coherent detection, in which BFSK generation, detection and error probability will be discussed. At the end, non-coherent orthogonal modulation techniques are to be discussed. The techniques are BFSK, DPSK symbol representation. We need to discuss about block diagram treatment of transmitter and receiver. Finally, end up with probability of error. For probability of error, we need not discuss about the derivation, we are discussing only about the probability of the error equation. The different types of basic modulation schemes which we will be using in transmission of digital data are amplitude shift keying, frequency shift keying and phase shift keying. The three basic modulation schemes of digital data transmission are amplitude shift keying ASK, frequency shift keying FSK and phase shift keying PSK. Whenever we want to transmit the data at higher rates through the band limited channels, we need to go for combined modulation schemes. The combined modulation schemes may be amplitude combined with phase, which is called as amplitude phase keying. Similarly, the phase again combined with respect to the quadrature phase amplitude, which is called as quadrature amplitude modulation. Similarly, we need to discuss about the demodulation also. Demodulation can be done either using the coherent receiver or non-coherent receiver. Here the demodulation process can be called as coherent detection if we are using coherent receiver. If we are using non-coherent receiver, it is called as non-coherent detection. In the case of coherent detection, there is a synchronized local reference of the transmitter signal, and the receiver will be having the exact knowledge of the carrier wave's phase reference. The receiver is said to be phase locked to the transmitter. I repeat, in the case of coherent detection, there is a synchronization between the transmitter and the receiver. The receiver will be having the exact knowledge of the carrier wave's phase reference. It means the phase is being locked between the transmitter and the receiver, and we tell that the receiver is phase locked to the transmitter. Coming to the non-coherent detection, here the knowledge of the carrier's phase will not be shared with the receiver. The knowledge of the phase of the carrier is not at all needed, and the receiver will not be knowing any information about the phase of the carrier. It will not be shared by the transmitter to the receiver. This is one of the advantage which will incur the less in the complexity of the receiver. Next, the question is why we need to go for the choice of modulation schemes. What are the desirable requirements? One of the most important desirable requirement which made to get into the choice of modulation scheme is maximum data rate. Maximum data rate, and we need minimum transmitter power. Similarly, we need minimum channel bandwidth, As well, we want minimum immunity to interfering signals. We want the circuit complexity to be less, which in turn results in the minimum cost. Finally, we need minimum probability of symbol error. All these desirable requirements as made for the choice of modulation schemes. I repeat, the desirable requirements are maximum data rate, minimum transmitter power, minimum channel bandwidth, minimum immunity to interfering signals, minimum circuit complexity and hence minimum cost, minimum probability of symbol error. Now let us discuss about these digital modulation and demodulation schemes. In digital communications, as we know, the digital data will be in the form of binary, ones and zeros, and it can also be block of n binary bits, which is encoded to m is equal to 2 power n possible discrete amplitudes, or it may be m is equal to 2 power of n discrete phases, or m is equal to 2 power of n discrete frequencies. Similar to the analog modulation, here also we consider the parameters of interest, amplitudes, phases and frequencies in order to build up the value of the digital modulation. This may be block of n binary bits. These n binary bits results in m is equal to 2 power of n possible discrete values. These discrete values may be amplitudes, phases or the frequencies. Whenever we go for m is equal to 2 power of n discrete values, we call such schemes of digital modulation as M-array signaling. M-array signaling. If suppose m is equal to 2, we call the signaling method as 2-array signaling. 2-array signaling, which results in binary value either 0 or 1. Either 0 or 1. Moving further, now let us discuss about the types of modulation. The first type of modulation is ASK. ASK. The full form is amplitude shift keying. Amplitude shift keying. Amplitude shift keying. Now, in amplitude shift keying, the amplitude of the carrier will have A volts for binary symbol 1 and value 0 for symbol 0. It means in ASK we are altering the value amplitude of the carrier. The amplitude of the carrier will be A for binary symbol 1 and the amplitude of the carrier will be 0 for binary symbol 0. Such modulation scheme we call it as on-off keying. On-off keying. It means on value for A volts and binary symbol 1, off value for value 0, symbol 0, we call it as off key. On-off keying. It will flip between 1 and 0. What is actually flipping here? The amplitude of the carrier will be flipping between 1 and 0. And since we are changing the parameter amplitude of the carrier signal, where the information of the message signal is residing, it is residing in the amplitude of the carrier signal. The information is carried by the amplitude of the carrier signal. Now, let us move on to the next type of digital modulation technique, which is called as frequency shift keying, FSK. Frequency shift keying. Frequency shift keying, FSK. In this digital modulation scheme, the information will be residing in the frequency of the carrier. The information will be residing in the frequency of the carrier. We will be having two different frequencies, one for symbol 1 and another for symbol 0. If there is a symbol 1, we take one frequency f1, and if it is a symbol 0, we take another frequency f0. Two different frequencies will be used, one for symbol 1, another for symbol 0. For symbol 1 we will use f1, for symbol 0 we will be using f0. Usually the frequency f1 will be more than the frequency f0. Higher frequency will be considered for symbol 1 and the lower frequency will be considered for symbol 0. Here the instantaneous frequency of the carrier, it switches between f0 hertz and f1 hertz corresponding to symbols 0 and 1. And in this digital modulation technique, the amplitude and the phase of the carrier remains fixed. Amplitude and the phase of the carrier remains fixed, only the frequency will be changed. Now moving further, the third type of digital modulation scheme is PSK. PSK. PSK stands for phase shift keying. PSK stands for phase shift keying. In PSK, the information resides in the phase of the carrier. In PSK, the information is present in the phase of the carrier. In PSK, the amplitude as well as the frequency of the carrier will be fixed, but what is the parameter that is changing is phase. There will be phase change here. Whenever there is a binary symbol 1, there is no phase shift. We tell that the phase as a value 0 radians. Whenever there is a symbol 0, there is a phase shift, and how much is the phase shift that is happening is pi radians. I repeat, the phase of the carrier is carrying the information of the message signal. Two different phases will be considered here. One is phase that is 0 degree, 0 radians or 0 degree phase shift, and one or more is 180 degree or pi radians phase shift. 0 degree phase shift will be for symbol 1 and pi radians shift will be for symbol 0. This type of modulation we call it as PSK, or specifically if we tell, this is actually called as BPSK, binary PSK, because here in this case we are considering only two binary values, either 0 or 1. So, it comes into the category of binary PSK, which is one of the type of PSK. This is about the discussion related to the basic digital modulation techniques, that is ASK, PSK and FSK. These are the waveforms of all the three types of digital modulation techniques, ASK, FSK and PSK. Let us take an example of a digital data which is represented as 0 0 1 1 0 1 0 0 0 1 0. Now, let us write the waveform in case of ASK for this digital data. This is my digital data, and the carrier in digital modulation, do not think that it is again a digital value in terms of zeros and ones. Our carrier is always a sinusoidal signal, a continuous signal. The carrier in digital modulation technique will be a sinusoidal signal, continuous signal, whereas the information will be in the form of a digital data. Fine. Now, if we go for ASK, amplitude shift keying, in amplitude shift keying, the frequency and the phase of the carrier remains constant. Only the amplitude of the carrier will be varied in accordance with this digital data. Amplitude of the carrier. The amplitude will be A for binary symbol 1 and it will be 0 for binary symbol 0. The amplitude will be A for binary symbol 1, it will be 0 volts for binary symbol 0. Accordingly, if I check this digital data, for 0, the amplitude will be 0 volts, again 0, the amplitude will be 0 volts. For 1, the amplitude will be 1, we are getting a sinusoidal wave of the carrier signal. Similarly, 1, again sinusoidal wave of the carrier signal which is having amplitude A, 0, so 0 volts. Again 1, there is a sinusoidal signal with amplitude plus A and minus A, again 0, so 0 volts, again 0, therefore 0 volts, again 0, therefore 0 volts, then 1. For 1, again we are having a sinusoidal carrier wave with amplitude plus A and minus A, 0, 0 volts. Like this, we are supposed to write the ASK wave considering a sinusoidal carrier and a digital information signal. Now, moving on to the next type, which is called as FSK, frequency shift keying. As we discussed, in frequency shift keying, if there are binary values 1s and 0s, whenever we are considering the binary value 1, we are taking one frequency, let that frequency be f1. If we are considering the binary value 0, we are considering another different frequency. Let us represent that frequency as f2. Two different frequencies will be used. For binary value 1, we are using the frequency f1. For binary value 0, we are using the frequency f2. Accordingly, if I check this waveform, as you can see here, for 0, we are using frequency f1 which is having only one cycle. For 0, again we are using frequency f1 which is having only one cycle. Similarly, for binary value 1, we are using frequency, I have written reverse here, I have taken 1 as f1, 0 as f2. If I just change this, with respect to the diagram, means waveform that we have considered, I will just change this accordingly. This is okay. I will make this as, for 1 I will make it as f2 and for 0 I will make it as f1. Now, if we analyze this accordingly, for 0 we are considering f1 as we have taken here, again for 0 it is f1 which is pertaining to only one cycle. For 1 we are considering f2 which is pertaining to, as you can see here, there are two cycles here. Similarly, for 1 again f2, as you can see there are two cycles f2, again 0 f1, again 1 f2, 0 f1, 0 f1, 0 f1. For 1 it is f2, for 0 it is f1. Like this, we need to distinguish between the binary value 0 and binary value 1, and this information in FSK will be carried through the help of the frequencies, two different frequencies. Now, moving on to the third type, PSK. In PSK, as we discussed here, for binary value 1, there is no phase shift, we tell it as 0 radians. For binary value 0, there is a phase shift of pi radians. This is what we discussed. Accordingly, if we take this digital data and if we analyze the final waveform of PSK here, as you can see there is a 0 here. So, whenever there is a 0, there is a pi radians phase shift. That is why the waveform is starting in the negative region, having a 180 degree phase shift. This is pi 1, this I can take it as pi 1. Similarly, again 0 is there, so it is having again 180 degree phase shift. There is a 1 here, so there is no phase shift, there is a 0 degree phase shift here, that is why it is starting at the 0th position and it is emerging from the positive axis, no phase shift. Again 1, there is no phase shift. Again 0, for 0 there should be a 180 degree phase shift. Again 1, there should be a 0 degree phase shift, 0, 180 degree phase shift. Again 0, 180 degree phase shift. Again 0, 180 degree phase shift. 1, there is no phase shift. Again 0, 180 degree phase shift. Like that, two different phases are used to distinguish the values of binary 0 and binary 1. And this case of digital modulation, we call it as PSK. This is about the discussion with respect to the types of digital modulation. and the discussion with respect to their waveforms. Thank you. Thank you.